The unit circle, Algebra 2 trigonometry regions. The unit circle is a circle centered at the origin with a radius of 1. And you don't have this, but I want you to draw this into your circle. Draw a little triangle in quadrant 1, just like I have drawn in here. And we're going to use this to show us why the unit circle is so important. So a unit circle has a radius of 1. That's why it's going to the point 1, 0. This is 1, this is 1. Any point the radius is going to be 1. And so this triangle that we drew here, the hypotenuse, this is the radius of the circle. So we know that this is going to be 1. And that's why it's so important. All right, so this would be a coordinate on a graph, and we know coordinates are made up of x comma y. And we know we can label our triangle with this being the x value and this being the y value, and that should make sense. Like if hypothetical point, like say this was the point 5 comma 7, we would get there by going to the right 5 and up 7. So whenever we label our triangles, we know the x value goes on the x-axis and the y value goes on the part that mirrors the y-axis. All right, but let's just keep it xy for now. And we know theta is always at the origin. Here's our little right angle. So what's so special about the unit circle is when we think about our functions like sine and cosine, sine theta equals opposite over hypotenuse. We know that for, SOHCAHTOA, and we've known that since Algebra 1 and maybe even earlier. But on the xy axis, the opposite side of theta is always that y value right there. So instead of thinking of it as opposite over hypotenuse, you could think of it as y over hypotenuse. And this is why when we did reference angles and ASTC and stuff like that, we kept saying that sine is the sine of y. Like when y is positive, sine is positive. When y is negative, sine is negative, because they're very much connected. And even more so on the unit circle, because on the unit circle, your hypotenuse is the radius, and the radius is 1. So instead of thinking of it as opposite over hypotenuse, just think of it as opposite over 1, which is just opposite, because we know over 1 doesn't really do anything. And y over hypotenuse is, again, y over 1. So you end up with sine theta on the unit circle equals y. It equals just the opposite, because there's no need to divide by the hypotenuse, because the hypotenuse is 1. So sine theta equals y. And that's real important. And cosine theta, which is your adjacent side over your hypotenuse, and on an xy axis, the adjacent side is always the x value divided by the hypotenuse. But when our hypotenuse is 1, we really end up with it just being the x. Let me get rid of that. So we end up with cosine theta equals x. And this is so important because ultimately what's going to happen is when we see coordinates on the unit circle, x comma y, we start to think of it as cosine theta comma sine theta. And so x is cosine theta and y is sine theta when you're on the unit circle, because there's no need to divide by a hypotenuse of 1. So this is real useful. Like, let me get to a quick example before I get to that table on the next page. If theta is an angle in standard position, terminal side on the unit circle, so on, so on, so on. So you're given a coordinate right here, 1, 2, comma, rad 3 over 2. And this coordinate is on the unit circle. What that means is sine theta equals the y value, rad 3 over 2. And cosine theta equals the x value, 1/2. So if you have a coordinate on the unit circle, just write CS above it. Cosine is this, sine is this. Tangent theta, we know, takes a little bit more work. You get tangent theta by doing sine theta divided by cosine theta. So that would be rad 3 over 2 divided by 1/2. And you could also think of tangent theta as y divided by x, because that's sine divided by cosine, right? And this is, we've talked about y tangents positive in quadrant 3 because sine and cosine are both negative, and tangent's a division of them. So anyways, multiply by the reciprocal when you divide fractions, and cross out, you get tangent equals radical 3. But the point is, if you're given a coordinate on the unit circle, you're given cosine and sine. Cosine x, sine y, Real important that you know that. All right, we want to fill in this special value table here. And to do that, I'm going to draw a couple of triangles to help us out. I'm going to draw the 30, 60, 90 right triangle, which is so important that if we have a 30-degree angle, then we know we have a 60-degree angle, and this would be our 90-degree angle. And I'll start there. So first, what is sine 30? Well, if I type that into my calculator, sine 30, my calculator tells me the wrong answer because I'm in the wrong mode. Should always check that. I need to be in degrees because I'm working with 30 degrees. So let me try that again. Sine 30 equals 1/2. We can convert it to a fraction, but we know 0.5 equals 1/2. So sine 30 equals 1/2. And your calculator will tell you that. It's a recognizable decimal. That's easy. What that means is the opposite is half the hypotenuse. But because we're working with unit circle stuff, let's pretend our hypotenuse is 1. So that means that opposite would be 1/2. Because sine 30 is opposite over hypotenuse, that'd be 1/2 over 1, which is just 1/2. And I'll save you a little bit of time, but if we do Pythagorean theorem here, we'd end up with this being radical 3 over 2. And that's also another really important decimal right there. So make sure you draw this picture, because that's what's going to help us. We could fill in another value here. We could do sine of 60. So sine theta of 60 degrees, here's your 60-degree angles. That'd be opposite over hypotenuse, radical 3 divided by 2. Now that's not as recognizable as 1/2 is. If you type in sine 60 in your calculator, it gives you 0.866. This is equivalent to radical 3 divided by 2. So it's really important that you make the connection between 0.866 and radical 3 over 2. So I'm actually going to write that on the table right here. Or I'll write it right above the table. That rad 3 over 2 is approximately 0.866. Now you're never going to write that 0.866. Like if I say, what is sine 60? You're never going to give me an answer of 0.866. The answer is rad 3 over 2. But if you type it into your calculator and get that, you can know that it means rad 3 over 2. So you want to recognize that. That's one of those things that's really important, that if you can remember that decimal means rad 3 over 2, it'll make a lot of this a lot easier for you. All right, how about cosine? Cosine 30 is also, here's my 30, adjacent over hypotenuse, rad 3 over 2. And cosine of 60, adjacent over hypotenuse, is 1/2. And notice that these are kind of opposites. Sine 30 equals cos 60. This has to do with something called cofunctions, which we're going to discuss in another lecture. So that's the 30 and 60 we get from this. The 45, I need to draw another triangle. I need to draw an isosceles right triangle. So 45, 45, 90. And again, we're going to say the hypotenuse equals 1. This works out to be rad 2 over 2. And this is the same, rad 2 over 2. It's an isosceles right triangle because they're both 45. So sine 45 is rad 2 over 2. And cosine 45 is also rad 2 over 2. I could go into a whole reason on why that's the case. Like if you made this x and did Pythagorean theorem, you'd have x squared plus x squared equals 1 squared. 2x squared equals 1, divide by 2, square root, rationalize. You're going to end up with rad 2 over 2. I'm going to save you a little bit of time and just tell you that. That is also a decimal you should know in your calculator, because when you type in sine or cosine 45, it's going to tell you 0.707. And if you can remember that radical 2 over 2 is approximately 0.707, it's going to make your life a lot easier. These are the only two decimals you need to memorize. Everything else here is easy. 1/2 is 0.5. You've known that. But if you can remember 0.707 rad 2 over 2, 0.866 rad 3 over 2, then this whole thing is going to be a lot easier for you. And one thing I want to point out to you is that the sign goes up. This is 0.5, 0.7, 0.8. So sine is increasing where cosine is decreasing. This is 0.8, 0.7, 0.5. So they're kind of inverses of each other in that sense. Then also, 1 over 2 can be thought of as rad 1 over 2. So it's like rad 1 over 2, rad 2 over 2, rad 3 over 2. It's always over 2. And cosine's the reverse. rad 3 over 2, rad 2 over 2, rad 1 over 2. So you can kind of remember that pattern, and it'll make all of this a lot easier. The next four angles here are the quadrantal angles. There's the ones on the axes, 90, 180, 270, 360. These we can easily type in and recognize them. So sine 90, sine 180, sine 270, and sine 360. And real quick, let me explain to you why that is the case. First, let me go back to the circle we have up here. Notice how this is the point 1, 0, because it's the unit circle. Remember, that's cosine and sine. This would be the coordinate, if this is a length of 1, of 0, 1. It's cosine and sine at 90 degrees. So sine of 90, remember sine is y, is 1, and cos of 90 is 0. So sine 91, cos 90, 0. And again, it makes sense because this is going 0.5, 0.7, 0.8, 1. This is going up to 1. This is going down to 0. And then the others, 180, 270, this would be 180 degrees right here. And it would be the coordinate negative 1, 0. So that means that cosine here is negative 1, and sine is 0. Sine is 0, negative 1. 270, this would be the point 0, negative 1. That means cosine is 0, sine is negative 1. And then the last one, the 360, is this point right here, 1, 0, cosine 1, sine 0. But you can just type into your calculator sine 270, sine 360, and it's going to give you these values, so that's pretty easy. Okay, I know this video is running a little late, and that tends to happen in this trig chapter, so I apologize for that. I want to do just one quick example with you. Cosine 210, and then I promise the video almost over. Cosine 210. First, you could get away with simply typing that into your calculator, cos 210, and that's going to give us the answer. But negative 0.866, you have to recognize that negative 0.866 is approximately the rad 3 over 2 decimal. So that's our answer right there. Why is it like that? How come 210's not on this table? If you remember the reference angle, 210, 210's in quadrant 3. How far is 210 from 180? It is 30 degrees. So this is a reference of 30 degrees. And at 30 degrees cosine, we have rad 3 over 2. The reason why it's negative rad 3 over 2 is because cosine's negative in quadrant 3. So your calculator is going to get you a lot of these values, and we'll practice this tomorrow. Sorry for the late video.